Gokul? Gokul, can we start?
1 second, sir.
One second. Gokul?
Sir, give me a minute. We will be going live.
Okay. I think Vamsi says we are live. Is it? Just check.
You can start, sir.
Okay. Friday Plus Plus is a new initiative from Techies that we started last month. The objective is to deep dive into some of the most happening technologies. The first series is on the electronics and semiconductor ecosystem, and we are doing this in partnership with Siemens. I'm Sujit John, and I have with me my colleague Shilpa Fadnis. The two of us will moderate the discussion. Last month, we discussed how everything around us is becoming intelligent, how our lives are being transformed by electronics. Today, we'll discuss the edge, how digital ecosystems are transforming every life through the edge. From autonomous cars and home automation to industrial IoT, edge computing is becoming the centerpiece. To discuss this, we have with us two veterans of the semiconductor industry. We have with us Ruchir Dixit. Ruchir is a country manager at Siemens EDA. Ruchir came to Siemens when Siemens acquired Mentor Graphics. So Ruchir has practically been with Mentor Graphics for 22 years now. For about half of that period, he was in the US. Ruchir is also the treasurer and executive council member of IESA, the India Electronics and Semiconductor Association. In all these years, Ruchir has either directly worked on or worked with customers on over 100 IC tapeouts. After spending close to 10 years in IC development roles, Ruchir moved into EDA, Electronic Design Automation. In these roles, Ruchir has worked with many customers worldwide and helped them to define the problem and then work to create solutions. Welcome, Ruchir.
Thank you so much, Sujit. What a pleasure to be here.
Thank you. And we have Sambit Sahu. Sambit is Vice President of the Network and Edge Group and General Manager of the IoT Engineering Group at Intel Corporation. Sambit leads a worldwide engineering team responsible for product design and development across IoT, intelligent edge, AI, client, and networking products. He has more than 30 years of experience in semiconductors, including 16 years in the US. Sambit has delivered over 70 groundbreaking innovative products and technology worth more than $100 billion. Apart from in Intel, Sambit has held leadership roles at Qualcomm, Sun Microsystems, and Procket Networks. Procket was acquired by Cisco. At Qualcomm, Sambit led the India Design Center. Welcome, Sambit.
Thank you, Sujit. Great pleasure to be here. Thank you.
Those who are viewing this, do send in questions through the comment section. Shilpa and I will put them to Ruchir and Sambit. Ruchir, first question to you.
Okay.
In the technology industry, almost everyone today talks of edge. The dictionary meaning of edge is it's the outside limit of an object, area, or surface.
Right.
Is it the same sense in which the technology industry is using the word?
Absolutely, yes. It is the device which is closest to where the decision needs to be made. It is the device closest to where the data is being captured. So essentially, just like a knife edge, it is this is the surface that is touching the object and the data that we need to capture. It's at the far end and closest to the consumer. So in that sense, yes, I would say it is very, very similar.
Okay. So it is the edge.
It is the edge.
Okay. Give us a sense of the kind of applications. Sambit, you want to start the kind of interesting applications that the edge is bringing to us?
Well, you mentioned a lot of wonderful applications already. I think the advantage of edge is few things, because today we have cloud. So where does edge coming. Okay. As Richard pointed out, edge is where it needs to be near the data. And any application that needs really very fast latency, like your driverless vehicle, okay, where decisions have to be made in the order of 1 to 3 milliseconds, that is where edge comes in. If I'm in a driverless car and there is a pedestrian and I have to brake, or the driverless car has to brake, then I can't go to the cloud because it will take around 50, 60 milliseconds and then brake. So I have to brake instantly as soon as I see the pedestrian. So the driverless car has an edge inside it. So that's one example. The second example in telesurgery, doctors who want to do some surgery with the help of robots doing some telesurgery, they want instant and immediate information so that they can make instant decisions. If they have to depend on the data to go to the cloud and come back, it could be a life or death situation. The other advantage of edge is where privacy needs to be maintained. Today, privacy is very important for all of us. I have cameras in my house, all around my house, taking photos 24/7. I don't want those images to go to the cloud because I don't know who is going to use those images, who is going to snoop on the images. I don't know that. I would rather have that privacy for myself. So I would rather process those photos in the edge of my home. I have an edge computer at home and process that and not send to the cloud. The third big application is all immersive experiences. You may have heard about virtual reality and augmented reality. In augmented reality, a physical object like myself is superimposed on a virtual background, and it should give a seamless experience. So that can be possible with the edge computing because it can very quickly superimpose things. And then the other advantage of edge or example is the amount of data and the cost it takes to transfer the data. The cost of transferring the data from a device to the cloud is 20 times more than the cost of transfer the data from the device to the edge. Okay, and in today's world, when there is so much of transfer happening, cost also becomes very prohibitive. So mission critical like latency applications, privacy, cost, and immersive experiences. These are the places where edge comes in handy.
Okay. This cost is interesting, 20 times more. Okay, we'll get more into that later. But Ruchir, you want to add to that?
I know Sambit has covered pretty much everything, but the thing that I want to add is, when we think of edge and the way I talked about it earlier, it makes it sound very complicated and something that a consumer or an average person may or may not see. The thing that we need to realize, and we should realize, is that edge is touching us almost everywhere already, the edge devices. On a simplest thing, my example, the wristwatch that I'm wearing, right? It is capturing my heart rate. It is capturing how many calories I've burned, all of that on my wrist. So that's the closest example of something that is very close to an individual consumer. Then somebody talked about areas where things might not be visible to an average person. So an example of an edge device in an industrial application might be, let's say there's a factory which has robots, which is picking up devices from A location and leaving them at the B location for the next set of operations that need to be performed. And let's say that the way this robot picks up devices is by creating a vacuum and picks things by creating a vacuum. Now, we need to know if the vacuum is still reliable, meaning what if some dust accumulated in the part that creates the vacuum? If the dust gets accumulated, the vacuum efficiency of the device will go over time and the robot will start to misbehave. So that means that as the machine is working, there is this edge device which is sitting on the robot, testing whether this vacuum creation capability of my arm is still robust, is it still reliable? So that is something that the consumer does not see, right? Then I think one example that I had talked about earlier as well, and people might resonate with it. I talked about the fish farms on the east coast of India, right, on the Andhra and Telangana coast. There are edge devices which are testing the water conditions to make sure that the farm still is healthy for whatever they are trying to rear in those farms. Yet another example could be in a hazardous location. Nowadays, people are trying to predict when volcanoes are likely to erupt. Back in the day, it was all based on grandma's tales that when this happened, I have heard that the volcano erupted. But now people have gone in and stuck in sensors into the ground close to these volcanoes and are looking for changes in the thermodynamics of the soil around the volcano and trying to see if this can give them an early warning of a volcano. So if it's about to erupt, they can notify the population to vacate. The one example that people in India will remember is the big tsunami that happened a number of years ago, right? Which caused a lot of devastation. And we had no way of predicting the populations around the world that, hey, a danger is coming. So now governments and companies have gone in and embedded sensors inside the ocean, which are now looking for abnormal water movement patterns in the ocean. So these are all edge devices. And as Sambit said, right, the data is being captured at the location and it is being processed at the location to make a decision whether an alarm needs to be sounded or not. Now, eventually this leads to the Internet of Everything discussion, which I think you will get to and I can talk about there as well. But these are some of the examples, some very visible to us, some which are not visible to the normal person in the day-to-day life, but is impacting our lives every day, regardless.
Okay. Yeah, we heard about these planes as well. Planes where, I mean, even as they are on the flying, you get the data. If something is wrong, by the time it lands, you know what is to be corrected and all that, right?
Absolutely, yes. 787 today in a 6-hour flight collects about 10,000 zettabytes of data. I mean, zettabytes, Sambit knows this, Sambit mentioned in the previous conversation that we had, is I don't even know how many zeros it has after the one to get to a zettabyte. And that data is being collected during the flight. Now, that data can be utilized for many things. And all of that data does not need to be processed at that instant. Right? Some of the data can be used for statistical analysis later on. But there is still some key data. What if the plane, the sensor on the plane decides or detects that a wing that was supposed to perform at a certain level is not? What if the rudders are not performing? The plane needs to know that right away. What if the engine is getting overheated? The plane needs to know that right away so the pilots can take corrective action. And if the pilots are for some reason incapacitated, the plane can take the decision itself. So those decisions need to be made at the edge. So eventually what ends up happening is, as the data is getting collected, somebody needs to make a decision what data needs to be processed now and what data needs to be processed later. And more data we need to process now, more of it needs to be done on the edge. Because we don't, like Sambit said, we don't have the luxuries of transporting it over, bringing it back. It might be too late.
Okay.
Basically, detect and immediate reaction, and particularly, in avoiding any disaster, like in an oil field or a gas. Okay, so or even in a manufacturing flow, there are so many heavy equipment. How do we detect quickly, immediately, and immediately react so that disaster is avoided?
Okay. Sambit, in that surgical example that you provided, where are the sensors, the IoT devices?
Well, there are sensors in many places, but most of the sensors are in the operating theater. The telesurgery is done through with the help of robots. So robots have sensors. They have cameras embedded on it. They have audio sensors, and then, as Ruchir pointed out, there are different vital signs sensors, the blood pressure or the heart rate and things like that. And all those sensor data goes to the edge computer. Okay, they're aggregated, and then artificial intelligence comes in to process that data and see and analyze that data and give some feedback to the surgeon. And this is all happening within milliseconds. So the surgeon can take the appropriate next step.
Shilpa?
Yeah, we hear about the confluence of emerging technologies, be it AI, IoT, 5G. If you can take us about the benefits and the features at the intersection of this confluence.
Who wants, both of you? Yeah.
Yeah, so Sambit, why don't you go first and then I will add on.
Okay. No, this is really these three technologies coming together, and I have seen many revolutions in my life: PC revolution, server revolution, smartphone revolution, and I played a key part in it. But the revolution that we are seeing right now with IoT, AI, and 5G or any other future communication technology, this is by far the biggest revolution that is happening. And I would say we are at the brink of this revolution. Next 30 years, there will be a lot of things coming out of it. And let me explain a little bit on what all these things mean, actually. IoTs are those sensors which kind of sense temperature, pressure, I think Ruchi mentioned about heart rate, radar, LiDAR, all kinds of things. So they're either sensors or they're actuators. Actuators mean which act, which take some action. So these IoT devices are connected to the internet, so they can pump in data to the internet, okay? And artificial intelligence is basically a computer trying to behave like a brain, okay? And today, very frankly, the best artificial intelligence, which is built out of neural networks, the best computer is really only 1% of human brain, 1%.
Really?
Yeah, 1% of one human brain, okay? So we have to first completely mimic the human brain. And there are predictions that by 2050, the best artificial intelligence machine will have the intelligence of the entire humankind. So you can imagine where this is going, okay? So the computers can make some intelligent decisions. For example, it can, after you train a computer, you can show it few animals, it can distinguish between a cat and dog. That's a very simple example. Okay. And then 5G. 5G is the communication technology. You're familiar with 4G, LTE, using smartphones. 5G is the next generation. And 5G is 10 to 100x better than 4G in different parameters like bandwidth, latency, reliability, power, things like that. It's okay. So these three coming together makes a big influence. For example, suppose we're in a very crowded places. There are 100,000 or more people in that crowded place. And we have to detect a criminal or an accused person in that crowd or a suspicious bag in the crowd. So there are cameras all around. The cameras are taking photos all the 24/7. And they're pumping that data to a cloud or edge as necessary. Edge if you need very fast response. And at the edge, there are artificial intelligence engines which are processing all the data. And with that data, they can immediately detect the criminal or the accused person or the suspicious bag. And then the machine or the edge will then issue instructions or alert the police or send SMS to all the people saying that there is a suspicious bag or there is a criminal suspect. Please evacuate that place. And all this data needs to be transferred very fast, and that is through the 5G. So you can see the IoT device or the camera is capturing all the video. It is sending it to edge, and edge has the artificial intelligence engine. The edge is processing all the data and saying, okay, there is this suspicious bag or there is this suspect criminal. And then it is triggering actions to be done. And all this data is being transferred very fast with a lot of high bandwidth to the 5G network. That's how the things work together.
So that's the confluence that Sambit is talking about, right? Where everything is coming together. The question is, why this confluence? Right? We can see it happening, but why? And so I'm a big fan of history and going back, and I always look at, okay, what has happened in the past and what is happening today to see what can be predicted in the future. So if we look at the fundamental things that changed the human life and which caused a huge economic upliftment of the humankind. The first age we can talk of as the metal age. Humans learned how to work with metal. And that caused a period of prosperity for the humans, because then humans were able to go get better prey, humans were able to go and grow better crops, and all of that happened. The second big thing that started the Industrial Revolution was the rediscovery and the ability to distill oil. That caused the Industrial Revolution. And now we are in a stage where data is really the new oil. The oil-based economies going in the future will eventually will be replaced by something else. But today what we have is everything is getting driven by data. And our ability to collect data from the device, the sense function that somebody talked about, is infinitely more than what we had it a few years ago. Now, as Sambit said, if we have infinite capacity to collect data, data by itself is of very little use. We need to first distill that data to collect information out of it. What does this data tell me? Based on that information, we then need to gather knowledge. Okay, what have we learned from this information? And for that, the data needs to be transported. Right. In our areas around us, and even in this session that we're having, majority of the data is being transported over either a copper wire or over a fiber optic network. And that has the bandwidth to transport all this data. But then there are applications where wiring may be impossible. Right? Sambit initially talked about oil refinery. And also, in an oil refinery, there might be a temperature sensor which is trying to sense the temperature of a certain part or a certain location in the factory. That sensor fundamentally is not any different from the sensor that we have in our air conditioners at home. We set the air conditioner for a certain temperature and it senses temperature. But the asks from those two devices is infinitely different, unimaginably different. At home, if the AC is set to 21 degrees, it goes to 19, we can put on a sweater. If it goes to 23, let's say sensor goes bad, an hour or two later, nothing breaks down. But in an oil refinery, if the sensor cannot send this data to where it needs to be understood, we have a problem. And areas where and I give another example of the volcano, right? We cannot lay a cable from this really hot volcano to the location where the compute is or the storage is. That has to go over the air. And that's what 5G enables. 5G enables the connectivity of these edge devices, which cannot be physically connected through a fiber optic or a wire, and take it over the air. So that's why this confluence is happening. Our ability to collect data, our desire and the need to collect data, our ability to process data has also grown. Companies like Intel and Intel's competitors have built these really sophisticated processors that can compute lots and lots of pieces of data in a very short time. And then that data needs to be transported. So that's what's causing the confluence.
Yeah.
And
I just want to,
yeah.
Sorry, go ahead.
No, I was just saying that, just saying what you said, Sambit, is that the prediction for the future is that this is only going to enter our lives even more so than what it already has.
Yeah, what I want to add here is that as per market research by ABI Research, this AI and 5G combination is going to enable close to $17 trillion economy by 2035. It's huge. And basically this confluence is the foundation of anything that you hear about smart homes, smart city. In India, we declared 100 smart cities, okay, to be built. Smart cities, smart manufacturing, connected healthcare, smart finance, anything that you hear today. The foundation is built upon this confluence of IoT AI, 5G, or future communication technologies.
Okay. But some use cases are possible even with 4G. But what you're saying is with 5G, it's going to explode, is it?
That's right, yeah, because 4G may not be able to deliver you that type of bandwidth, that type of latency for mission critical applications like we talked about driverless cars, okay? Or 5G also gives you that kind of capacity. But in smart city, you want many devices, to be concentrated and to be connected with each other. And 5G's capacity in that situation is around 100 times more than 4G. 5G can accommodate 1 million devices per square kilometer. So that means 1 million sensors, actuators can all communicate over the air through 5G within a kilometer boundary.
And you're right, Sujit. Not everything needs 5G. Right. So if we look at IoT, we should actually start calling it IoE now, Internet of Everything.
Yeah, you mentioned that last time as well. So
Yeah.
what? We're going to see a world where practically everywhere we're going to have sensors, including on us, is it?
Yeah, we already have.
Well, on us, we already have sensors. I'm wearing one.
Yeah.
I'm sure people, some of you are also wearing one, and our audience is also wearing one. Everything will get connected. So I will give an example. We check into hotels, and nowadays the minibar at the hotels has things in the minibar which are sitting on a sensor. If somebody lifts a bottle out of the minibar or a packet of chips, automatic billing happens. Right? So it's already there. Right? Now, when I talk of Internet of Everything, there was the first fridge introduced in South Korea about 15 years back, which had the ability to auto-order your supplies based on what it saw was depleting in your refrigerator. Because it had sensors built into every shelf, and you had a designated shelf. If you were running out of milk, the fridge automatically placed the order to the local reseller that you prefer to buy from. That was 15 years ago. And those things will keep coming. Right? So when I say IoE, there is IoE, and then there is what I call advanced or extreme IoE. Extreme IoE is what Sambit has been talking about, and I have talked about, that where we need to make instant or immediate decisions. That needs a very fast network to get the data across, if there is a need to data. So first thing Sambit said, right? First thing is, let's try and minimize how much data we need to send to the server on the cloud. But there will still may be a need for some data to be transported. So let's find the way which is the fastest. Then there might be some applications where it need not be that fast. Medical examples, since we're talking of medical examples, every X-ray that is taken at a hospital, some decisions might need to be made by the doctor at that time while the doctor is performing a procedure. But then there might be, or there are cases where on the cloud, a machine which is based on machine learning or artificial intelligence, which is nowadays used interchangeably, is analyzing millions of X-rays coming in and then trying to find commonalities in those X-rays and saying that, hey, if I see these commonalities, this looks suspicious, this looks dangerous, and this is benign. All of that data can happen in the background. That does not need instantaneous decision. And that can go on a slow speed network. But again, yours, mine, and everybody here, our attention span, you would have noticed, has diminished significantly over years. We want quick answers all the time. So what will happen over time is that fast enough will not be fast enough. We will always need something faster. So today it's 5G, 6G will come out, fiber and all the other technologies will also get upgraded to make this data transport and the compute and the sensing and the actuations faster than what they are today. But yes, everything will not need to go at the same speed.
Okay.
I want to just add to that. It may sound simple, it may sound very exciting, but the amount of work behind that is quite significant.
Yes.
There is lots of innovations happening, and the bigger thing is that there is lots and lots of collaboration happening. Okay, collaboration between cloud companies, edge companies, IoT companies, software companies, hardware companies, technology companies, process companies. Everybody is coming together, and this whole revolution needs software, hardware, technology all to come together.
Yes.
So
Okay, that's something I wanted to ask you. I mean, what finally enabled? I remember, years ago, it was an IESA conference, I think, and I was speaking to Dasharatha Gude that he was the first person I heard this, that you will need these specialized chips for IoT was just emerging at that point, I think, and he said you will need these specialized chips, and he said he's working to develop one and all that. I think Intel finally acquired his company, if I'm not mistaken. So. So what finally happened? I mean, these are you require very specialized kind of chips that less power consuming, more powerful, and all that, is it?
well, it depends. Of course, the IoT devices, which is the sensors and actuators, which go into a fridge or a watch, they have to be very small, very, very low power, because these are mostly battery operated devices. Okay, like my wristwatch is battery operated, so very low power devices. They call the embedded devices. They have limited capability. Nowadays, we are also trying to put some amount of intelligence into it. Okay, and so that is one extreme. The other extreme is cloud, where all, as Ruchi said, all the heavy duty processing happens. All the artificial intelligence training happens. All the big aggregation happens. So those are very powerful multi-core computers, and not just one die, they're one chip. Multiple chips are put together into systems and racks, and that's how the data centers are built. So that's the other extreme, very powerful computers, computers. And then edge is somewhere in between. I think edge has all the characteristics of cloud because it needs all the functionality of the cloud, the storage functionality, the compute functionality, the artificial intelligence functionality, plus few other technologies to deliver these mission critical applications, time sensitive applications, or functional safety applications. So edge is in between, with the right balance between cost, power, performance. So you have the entire spectrum, and not only in the hardware, also the software, also the same thing. There are different pieces of software. There are smaller elements of software in the sensors actuators, which does one particular function to sense or act, versus cloud, which does all different kinds of applications, different kinds of processing, and edge is again somewhere in between. And edge also, since it's an evolving field, the different types of edges you will hear. Near edge, which is near to the device. Far edge, which is little far from the device. Edge near the cell tower, because your cell tower base station that process all your 5G workloads or 5G requirements, they also need some edge computing. So that's called mobile edge computing. So there are all different types of edges involved.
Okay.
Yeah, Sujit, what Sambit is saying is absolutely right. And one thing that our industry has learned over the last 45, 50 years is that there
There's
are
some noise coming. Sorry, Ruchi. Is there some squeaky noise that anybody hears?
yeah, it's coming from my UPS.
Oh,
But
is it?
yes, so I'm sorry about that.
Okay. No.
We just had a power failure. So
Okay.
let's see what happens. Hopefully I can stay alive until the end of the session.
Okay, go on.
If it's too disturbing, then I can log off for a couple
I was
of minutes.
wondering
And
whether
then
it's some system. Yeah. Okay.
if
Go
it's too
on, Ruchi.
disturbing.
You are saying?
So I was saying what we've learned in the last 45, 50 years is that there are certain kinds of problems which need a very specific algorithm that needs to be implemented in the hardware to solve it. And creating a general purpose IC chip to do everything doesn't really work.
Okay, I think we lost Ruchir. This is a problem in Bangalore, major power issues. I know, and if it goes on for too long, then even the UPS fails. Yeah.
We can continue if you have.
Shilpa?
I hope I'll try to cover for Ruchir in a.
Yeah, I guess Ruchir will come back shortly.
So, Samit, do you want to take us through some of the products and applications that Intel and Siemens are developing in edge computing centered around the Confluence?
Yeah, Intel and Siemens has been partnering for many years. Actually, we have a very interesting relationship. both of us are producer and consumer of each other. Intel, we started with Mentor tools, which Siemens acquired. And I know Ruchir from the Mentor days, and we still use a lot of those tools to build our chips or FPGAs. These are called the EDA tools, different type of EDA tools, and we use that. And for our IoT and edge computing, Siemens is a key customer and partner, and we're collaborating in many areas. We delivered few products for them for their factory automation and as also healthcare analysis. Basically, we provided the edge computers which Siemens has deployed in their factories and also other places to automate the factories, to identify problems in assembly lines, to identify problems in machinery quickly, to alert systems, and to analyze a lot of the data coming in the factory and making those intelligent decisions that we talked about. So Intel provides the hardware and some amount of software stack that goes with it to Siemens, and Siemens then proliferates that to itself and its customers in the factory side. Similarly, on the healthcare, there are a lot of partnership happening. How do we manage healthcare better, and how do we aggregate healthcare data to make intelligent decisions? We also partner with Siemens on the oil and the gas example I provided, that these computers can go into the oil refineries or the gas refineries to identify challenges, problems, and immediately react. So we partner with Siemens on that. So there are many areas we're working together, and it's a continuous partnership. We continue to develop better and better products, richer and richer in technology or applications. So, and we closely collaborate with Siemens to understand their needs, their requirements, to co-develop, to test things out. So it's a continuous partnership.
Sambit, I just want to clarify. I mean, the sensor.
I'm back. My video is still not
Ruchir,
on, but I can do the
see.
audio. I can do the audio. And thank you so much, Sambit, for saying that. And Sambit, again, covered pretty much everything, right? If you look at Siemens, Siemens has two parts. One is systems is a systems provider to the marketplace. Now that system can be as large as a wind turbine, can be as large as an electric train, or could be smaller IoT devices that go into the factory, which enables Industry 4.0. So the way this partnership that somebody talks about works is that system needs components and intelligent components. And Intel becomes a supplier of those intelligent components to Siemens, which then Siemens puts them together in a system that can be deployed in the world. Something similar to a laptop, right? Intel's processor goes inside a laptop. The laptop becomes a system that then becomes available to the general consumer. So that's where this one side of the relationship between Siemens and Intel is working in the market and working with the consumers. On the other side, as Sambit briefly mentioned, there is a collaboration between Siemens EDA and Intel on helping Intel build those devices. Like we have talked about in the past, the devices that Intel makes are so complex that it requires advanced software to help Intel design it, manufacture it. So that's where the other side of the partnership comes in. And it's been going on for years, at least in my career that I've been in the industry, Intel, and back then it was Mentor, that partnership was there. It's still around, very strong. And the way the Siemens EDA and Intel is impacting the world and coming up with new solutions, both on the design side and all the system side, with Intel in the middle supplying on all the intelligence that goes into those systems. I see this partnership becoming stronger over the years.
Okay. So those at the edge, the chips that are used, those those will differ from use case to use case, is it?
Yes, absolutely, yes. My wristwatch, back to my wristwatch. There is one device which is counting my heart rate. And for that, it needs to send in a light pulse through my skin and collect the reflections of that light pulse as it comes back from the blood vessels that are under my skin on my wrist. So that device is specialized to transmit light and receive light back and measure the difference to see whether a pulse happened or not. That's highly specialized in that. There is a second device on my watch which is counting my steps. How many steps have I taken? That device is based on a gyrometer, which sees how much movement, physical movement, my hand has done. And it needs to decide whether this can be counted as a step or not. And that device is, again, highly specialized. So not just a device in different systems. Within one system, there are different IC chips, different hardware parts that are super specialized to do what they are designed to do. Then it connects with Bluetooth. All the data that is captured by my wrist transfers to my cell phone on the app. That happens on Bluetooth. And there is a dedicated piece of silicon to take care of that function. So simple example, what's on my wrist. Now imagine applying this same concept to everything that we, Sanbit and I, have talked about in the applications. Everything will require a specialized sensor. Another example that I quoted earlier, temperature sensor on my air conditioner and the temperature sensor in the oil refinery. Although the intended function is the same, but then the surroundings and the context of those two functions is so different that it will have to be, again, specialized. It will have to be designed for that unique context of that function.
Even your iPhone can act as an edge computer. It has so many sensors, as you know, audio, video.
Okay.
Yes.
Okay.
So many sensors. It has some intelligence process things. And for heavy duty processing, it can send to some more powerful edge, in your community or in your factory floor, or you can send to the cloud. So your iPhone also can be used as an edge computer.
Okay. And Sambit, it's your team that is building it for the world, huh?
Well, I'm not building iPhones.
Not iPhone ones, not the iPhone ones, but the other ones that we talked about earlier.
Yes. We build the bigger scale edges, the more powerful edges that go into the factories, big department stores, and things like that. So,
okay.
Yeah.
Fascinating. Shilpa?
Yeah, we have this question from one of our viewers, Shivangi. Are the creators of AI mindful of the ethical aspects of creating it?
I'm sorry, can you?
Yeah, this is from Shivangi. Are the creators of AI mindful of the ethical aspects of creating it?
Ethical aspects of, okay. No, that's a great question. Ruchi, shall I go ahead?
Ruchi is muted.
Okay.
Please do.
Yeah, no, that's really a fantastic question. One of the challenges of AI is how do we deal with ethical issues? Okay, if AI is, like I said, like human brain. If I tell the human brain that this class of people, if I train the human brain that this class of people are the people from this country, that they are they violate law or they're unlawful. If I train my brain like that, then when my brain learns that, and I see a person of that country or of that color or caste or whatever it is, then I am already biased that probably that person is, and that's very dangerous. So the computer also has the same problems. If I train my AI engine saying that this class of people or this sector people, they're unlawful or stay away from them, the computer learns that, and the next time the computer sees that kind of person, it's already biased that that person is falls in the same category, which is really dangerous. You can't generalize that. So that's some of the ethical problems of AI. The second is, we are building robots, we're building all these sensors, we are building different types of computation, drones, AR, VR, all kinds of things. If they fall into wrong hands, it can create havoc. Definitely there are a lot of challenges with AI. The good news is that organizations, countries, consortiums are all actively working in understanding these ethical problems of AI and trying to come up with standards and mechanisms of how do we manage that. So that's the good news. But the AI is developing so fast that this ethical consortium or ethical bodies have to keep up with that. Go ahead, Ruchi.
Yeah, Ruchi, I have an interesting question here from Prajwal Kardam. By what year do you think India and its citizens can reap the benefits of 5G, AI, and IoT, IoE, whatever confluence?
That's a very interesting question.
Ruchi, your voice is a little not
Okay,
as.
is this better?
Yes.
Okay, because I'm using two devices now. We were talking of Internet of Everything. I'm using my phone for the audio and my laptop phone for the video and the laptop for the audio.
Okay, that's interesting.
It's a very interesting question because it has two components, right? One is the technology part, and the second is the availability of the technology. So if we just remove 5G from the discussion for a few seconds, we are already seeing and we are already taking advantage of the edge technology that we've been talking about. And I've given, and Sambit has given many examples of how it is touching our lives today already, with or without us realizing it. When it comes to 5G, 5G has some regulatory issues because we are talking of sending data over the air, which means that we're going to be sending waves into the air. And the waves and the region in which these waves can be transmitted needs to be controlled very carefully. Otherwise, it creates confusion and it can create some interference. Simplest example is when we take a flight. The flight path of that plane and every single plane in the sky is tightly controlled by air traffic control because we don't want one plane getting into the way of the other plane. Same way, when we start sending different kinds of waves into the sky, we want to make sure that this data is reliable because Sambit talked about it in the very beginning. If the data that is being transported, if we cannot rely on it, the data becomes irrelevant. Unreliable because of interference, unreliable because of maybe somebody with a bad intent who intentionally corrupts the data. So what ends up happening is that for each technology that needs to go over the air, each government decides a specific band of frequency that is allowed and that can be used by people who want to use it. So that's the regulatory part. I'm hoping that the bands in India, because in India we follow the auction principle. When the auction happens, enough people come in to bid. And once those bands are sold, we will see the services becoming live very quickly because the technology already exists to take advantage of it.
Yeah, and I just want to add, even today, there are a lot of examples in India and a lot of startups building products using IoT and AI in many ways, in smart cities, even smart agriculture. In agriculture, something called precision agriculture, where you can put different kind of sensors in your field, and they can measure your temperature, your soil efficiency, and environment conditions and all these things. And then using intelligent techniques, you can formulate a recipe of how to improve your crop yield or how to improve your agriculture yield. So many startups are starting to work on a lot of these technologies using IoT, AI and some communication mechanism. In India, a lot of it is still 3G and 4G. Is some okay, but over time, as 5G rollout happens, 5G will come in and increase the quality of service or increase the experience and the impact of it. But
Absolutely.
a lot of wonderful startups really doing work with IoT and AI already.
Yeah, absolutely. And India has the potential to be the data capital of the world. I have no doubts about that. We not only have the technology, not only do we have the talent, but also all the other factors, the economic growth that we have seen in the country in the last 15, 20 years has put us at a place where we are ready to take advantage of everything coming together. A confluence of things, a word that if I can steal from your vocabulary and Sambit's vocabulary, all the building blocks of us taking advantage of it are here, and we just need to take advantage of it. If you really believe what I said earlier, that data is the new oil and we have the ability to capture and process most of it, we are very well placed.
Yeah, one thing I want to point out that Intel is coming up with some technology with the IoT and AI, and for oral cancer, and we are embedding those technologies into mobile cars and trucks to go out and screen for oral cancers in the country.
Oh,
It's a combination of IoT and AI technologies.
wow.
You spoke about how India is, poised to play a significant role in the semiconductor and electronics ecosystem. But from a talent standpoint, if you can talk about how we are well placed to capture this demand environment.
Shilpa, is that something that you want me to talk about?
Yes, yeah,
Okay,
please, Richard.
Yeah. See, talent has, again, two components. One is the quality of the talent. Second is the quantity of the talent. There is no doubt in my mind or anybody else's mind anywhere in the world that the quality of the talent that we have in India is as good or better than any other part of the world. There is no doubt in anybody's mind. And that is the reason why we see all the large companies across the world clamoring to open their design centers in India. And once they open the design centers, they just keep on expanding. The number of people that they have is readily deployable, and the learning curve is as steep as possible and as short as possible, so that we can take advantage of all this demand that we have created. And the reason we have created this demand is because of people like Sambit and others who have proved to the world that our talent and quality is as good or better than anybody else in the world.
Does the edge require any niche skills compared to the rest of the semiconductor industry?
Edge requires a wide variety of talent. It requires software talent, systems talent, semiconductor talent, pretty much the entire gamut of talent. And I would say in terms of software systems, applications talent, we have lots in India, as we have seen over the years, and the number of startups, number of innovations happening. We see lots of good talent in India. In semiconductor talent, which Ruchi said, definitely we have seen significant growth in the last 15 years, and it's only getting better and better. But the demand outsmarts or outplays the supply we have. Okay, and so that's where we need to focus more, and not only grow the talent, have more talent, but also make the talent more innovative, more creative. And that's what we need to work with universities, government, and others, really, how to propel that. But in terms of software, application systems, talent, that is huge, as you can see from the companies and the history, as well as the number of startups and the quality of the startups is magnificent.
Absolutely. From whatever we hear, some phenomenal work are happening out of India. Yeah.
Yes.
Shilpa, I have a question here from Bishwajit Patra asking, what key innovations need to happen over the next 5 years on the software and hardware side to unlock the benefits of the 5G networks? Anything?
Well, the 5G architecture has three main components. One is ultra low latency, Second is high bandwidth, and third is maximum density. These are three. Okay. Now, the thing is, different applications need different type of functionality. Some things like driverless cars need ultra low latency. Some things like video transfer or video processing need high bandwidth. And then the smart cities need high density. So for the same network, you have to draw three different type of applications. So really, how do you, from the same network, slice, and it's called network slicing. How do you slice that network so that you can serve the three different diverse applications effectively is a big thing. The other thing research that's going on in any communication technology, how do we save energy? Because we have to make a sustainable world. The more of this data, more of communication, more of technology means more energy, more carbon, CO2 emission. So a lot of research going on. How do we make it sustainable? So a lot of work going on there in the networking side on how do we make energy efficiency and reduce the CO2 emission. So those are the two big areas, but there are lots of areas. Research is so many places, so many areas.
Yeah.
So go ahead, Shilpa.
Sorry, go ahead, Richard. We had 2 more questions. So yeah, maybe we'll take it after you share your thoughts. Yeah.
I just want to add to what Sambit said, right? Sambit focused on the intricacies and the details of the 5G technology. And if I step away a little bit from 5G and defocus on it, because in 5G creates this, in simpler words, a highway structure to move data. Now, as research goes on to build that infrastructure and highway infrastructure more efficient and more usable, I keep going back to data is the new oil thing. As the infrastructure gets built, what we will need to continue to innovate on is our ability to capture data very, very quickly and very efficiently, and our ability to process this data very efficiently. And that's where machine learning will start to play a very important role, because we will have to now start talking about learning from what we have learned before and not having to learn every single time a new situation is presented to us. So more and more machine learning based algorithms will start to come into place, where past learnings will be applied to take current actions. Energy is something that somebody talked about. All of this has to be done in a very power efficient way. And then the other area that we will need to start working on is the compute that needs to be done and the storage that needs to be done on the clouds. How do we minimize the need for that? So these three areas in my mind: one, at the data capture side, some bit focused on the data transport side, and then on the cloud side, the efficiency of our functions that we perform will be the key.
Yeah.
Okay.
Just want to add just a couple of statistics important. The amount of data that is going to be generated in the next 3 years is more than the data that was generated in the last 30 years because of all the streaming services, Netflix, Hulu, and all these things. That's number one. Second is 90% of the data today that is generated is dark data. Dark data means the data is not used for anything meaningful. So as Ruchi pointed out, how do we manage this data explosion? And how do we intelligently derive meaning out of the data and know how to ignore the dark data? Because 90% data is dark data. So those will be the critical challenges here. Yeah.
Okay. So ML at the edge kind of decides also, okay, what to send to the cloud and all of that, is it? Otherwise, there'll be too much data going into the cloud.
It will have
exactly.
to. Yeah.
A factory, in a factory per day, per camera, it generates 2000 terabytes of data. Only 1 terabyte of data needs to go to the cloud. The ratio is 1 to 2000. Wow. So you can imagine how much edge can be valuable and processed so that we don't inject so much into the cloud, because more data you inject to the cloud means more bandwidth cost, more security problems. You're overburdening the cloud and things like that. So in a factory itself, per camera, per day, 2000 terabytes generated, only 1 terabyte goes to the cloud.
Wow.
It's the simplest and a funny example of that. We all watch these crime TV shows, right? And every once in a while, the police is looking for something on a CCTV footage. And that's exactly what somebody is talking about. For that 3 seconds of CCTV footage that they might find something useful, they have to go through days and days worth of CCTV footage. Right? So imagine a machine doing this for us, where the machine says automatically based on what it has learned in the past, and it narrows down the search space for us so that meaningful information can be derived in the timeliness that is desired.
Okay, interesting. Yeah, Shilpa, you had said two more questions.
Two more questions. Yeah, this one is
We
from
have time,
Prasad.
right? Sambit, Ruchir?
Yeah.
Yes,
Okay.
yes.
Okay,
5 minutes. Okay. This one is from Prasad Bhatt. Is there a limit for the lowest possible latency for solving real-time use cases through edge computing? Is there a Moore's law equivalent for this?
It's a great question. Different applications need different type of latencies. But I would say the mission critical, the real-time kind of things would be less than 5 milliseconds. And 5G supports, in a good 5G supports 1 millisecond of latency, which is a good news. Okay. But anything less than 5 milliseconds is probably acceptable for most applications, I would say. Moore's law is of this latency and things like that. I think we have to think about it. I don't have a good answer really how to correlate the Moore's law when we are packing 2x transistor every generation. How that will translate into latency. I think we have to think about it. It's a good question, by the way.
Yeah, and the other thing, other thing I will say is that,
What is that?
sorry. My power just came back on, and that's creating a big problem. So hopefully this is not causing any major problems.
No, it's fine.
Yeah. Unlike Moore's law, not unlike, kind of like Moore's law, we still have a physics limit on how fast we can transport information. I don't think we have figured out a way to transport information at a speed faster than the speed of light. So that will always remain a physical limitation for us. Sambit said that 5 milliseconds is a good estimate to have for mission critical and applications that need immediate decisions. I am quite certain that as soon as we say this, in a few years, somebody's going to come out and say, I need a decision to be made in 1 millisecond. Right? So no matter what number we come up with, somebody's going to come up with a need which is faster than that. But there will be physical limitations, because still the data needs to be captured. If it's a camera, the camera needs to record the image. Then the image needs to be broken down and processed to understand what this image is. And on the backend side, because all these devices and systems are based on semiconductors, in a way, Moore's law will, or a variance of Moore's law will still apply. How fast can we process information based on the technology that we will have available at that time? Today, what Intel is making chips are thousands of times faster than what they made 10 years ago. So that need of speed will always remain, but eventually it will hit a physical boundary.
Yeah. Actually, you got me excited, Ruchir, by talking about speed of light. We are doing research on optical chips, optical I/O, to transmit and receive data at the speed of light. So we are doing that. Okay, so if things work out, in the next few years, we'll have some good products.
Yes, based on silicon photonics.
Silicon photonics that receive, transmit data at the speed of light, and hopefully the processing can keep up to that.
Can keep up with it, yes.
At the moment, for autonomous cars and all that to brake immediately, or we have the technologies there.
Yes, technologies are there. Autonomous cars don't need so much of data to go at a speed of light, as long as we are able to process and react within 5 milliseconds should be okay. And I think a lot of autonomous companies including Intel, and that we have chips that can cover that kind of
Cater to
latency
that.
requirements.
Okay.
Or that type of also aggregation of data requirements.
Okay. Shilpa, then we'll make this the last question.
Last question. Yeah, this is from Vasant. What is beyond 5G, AI, and IoT?
Well, you will hear about 6G. AI, as I said, today we are only at 1% of the human brain. And even to do that 1%, it requires kilowatts of energy, okay, kilowatts of power, okay. The whole brain only takes 20 watt of power, okay. So how do we take the AI to be like a human brain with 20 watts of
Long
power?
way.
Long way, yes, long way, lots of work happening there, okay. And then there is talk about 6G, which would enable lots of machine-to-machine interactions, without the intervention of human beings. How there's a lot of research going on in 6G, and IoT is there is a lot of work going on, which is called tiny ML. How do we embed some intelligence into the sensors and actuators so that they can do a lot of the processing themselves and make quick actions, not even transfer to the edge. Forget about cloud, not even transfer to the edge.
Great.
So that's called tiny ML, which is tiny machine learning. A lot of work going on there. And again, it will depend upon the innovations that we all come up with. You all come up with innovations. But technology is limitless, and applications are limitless.
And Ruchir is giving you the tools to do that. Huh?
Yeah.
It is hard to keep up with what a leader like Intel needs, but we have been at it so far. And the good part about this collaboration that we talked about earlier is that, like Sambit's team, right? Whatever Sambit's team is working on today is not what the market needs today. It's what the market will need 2 to 3 years from now. So, Intel looks at the market needs 3 years out. Same way we look at what is required and what will be required 3 years out. So we're always looking out in the future, because what we are delivering today was done 3 years ago.
And I want to say that I think collaboration among companies is extremely important. Okay, collaboration within software, hardware, EDA, all the companies with different skills. Partnership is important. I mean, even today, the demand is so high, but the chip supply is limited. There is quite a gap between the chip demand and chip supply. So companies are coming together to really see how do we manage that crisis? How do we partner together to manage that crisis? So collaboration is extremely important. And yeah.
Okay. What a fascinating discussion. Now, I know, as Sambit said, this confluence of IoE, AI, and 5G could be the greatest revolution the world has seen. And what, by 1950, AI will have as much brain power as the whole planet, is it? Amazing. Okay. I know, absolutely fascinating discussion. I'm sure we'll see these phenomenal technologies emerge over the years. Thanks so much, Sambit. Thanks so much, Ruchir. Great discussion. Hope to have you again on this platform some other time.
Thank you for the opportunity. It was a pleasure to share this panel with Sambit. You used the words earlier about Sambit and a veteran. I don't want to use that word, but somebody who has driven this industry to where it is.
Legend would be a better word, huh?
No. I don't deserve all that. It's great to be in this panel, and I know Ruchir for 15 years. Have been great partnership, and partnership can be strong, and really appreciate Times giving us this opportunity. Fantastic. And I think we'll all do this together, and India is booming right now, and all of us will work together to make a great India and shape up this technology future, and capture a big piece of that $17 trillion economy by 2035.
Yeah.
Yes. Stay tuned. Exciting times ahead. Stay tuned. Exciting times ahead.
Absolutely. Yeah. Thanks so much to Siemens also for partnering with us. Okay.
Thank you.
Thank
Bye.
you. Bye.
Bye.